Good morning, grade 9. Okay. We are now in the second part or second module of the third quarter. Okay, this is weeks 5 to 8. This is good for 4 weeks also, right? Entitled Climate. What's in the climate? What are the effects of these climatic changes? How we are affected with this climate? These are just few of the details or information that we'll be tackling in this module, right? Factors affecting climate. Okay, climate is the average weather condition in an area over a long period of time. Okay, since this is a long period of time, we are having these climatic patterns. Okay, but because of some factors that affects climate, these patterns changes from time to time. Various climate in Earth are defined by the amount of energy it receives from the sun. Okay, remember the radiation from the sun? This radiation also affects climate, which is based on the angle and location at which sunlight strikes Earth. Each one is affected by several factors, including latitude, global wind circulation, Yoramihan Yorabagat, bodies of water, topography, altitude, and vegetation. Let's take a look at latitude. Okay, latitude is the distance, okay, from north or south of Earth's equator. Okay, areas near the equator receive high amount of solar radiation. We are actually located there near the equatorial line. Solar radiation and temperature. Earth's shape and angle primarily cause the differences or difference in amount of heat absorbed by a region. Such differences or difference is also affected by the distance of the region from equator or latitude. Okay? The temperature at region near the equator is higher than the temperature near the poles. Of course, remember that Earth is tilted, okay, and Earth is not spherical, okay. Let's move. Again, the temperature at the region near the equator is higher than the temperature near the poles, okay? Because Earth is not spherical again, it is oblate spheroid, okay? Polar regions receive the least amount of solar radiation and temperature. There are three climatic zones on Earth with respect to the latitude. If we'll be considering the latitude, okay? The tropical, polar, and temperature or temperate zones. Again, the tropical, the polar, and the temperate or temperature zone. Okay? Tropical zone or the low latitude zone extend 23 degrees north latitude, that's the Tropic of Cancer, to 23.5 degrees south latitude, that's the Tropic of Capricorn. In such zones, sunlight strikes Earth vertically. Dry and wet seasons, due to high temperature, rain, and humidity, are experienced by areas in the zone. Okay, our country, Philippines, lies in the tropical zone. Okay, it experiences high temperature, of course. We're also humid, high humidity, and of course, abundant of rainfall all over the year or all year round. Okay, if you're going to look at the diagram, as you can see, we are in the tropical zone. This is the tropical zone. Okay, this is the temperate zone or temperature zone. Okay, and this is the polar zone. We are actually in the near the equatorial line. We are near the Tropic of Cancer. Polar zones are located at the poles from 66.5 degrees north and south latitude. Less sunlight strikes Earth's surface at a very flat angle. Again, because if you're going to look at the position of Earth, it is not straight. Okay, it is actually what? It is with an angle. And again, it is not spherical, but of late spheroid. Okay. Cold weather patterns and very little precipitation. Precipitation means rainfall are experienced in such zones. These include the polar ice caps, island of the North Arctic Ocean, and southern Antarctic. Okay. Temperate zone or temperature zones, okay, are between the tropics and the polar region from about 23.5 degrees and 66.5 degrees north and south latitude. Okay. They receive an amount of sunlight in between the tropics and polar zones. Okay. Weather in those zones generally changes in seasons. They have seasons actually. Okay. Namely winter, summer, spring, and autumn. That's the 4 seasons there. Simply because they receive an amount of sunlight between the tropics or tropical zones and the polar zones. They're in between. Okay. Winter has a cold temperature. Summer has the hot temperature. And spring and autumn have the mild temperature. This is the reason also why some of the birds migrate. Have you observing them? Okay. Why some of the birds migrate from these zones, the temperate zone? Because of lack of food. Okay. Talking about winter is very cold and they cannot actually adapt to that change of temperature. Okay. Birds needs a humid temperature. Okay. They need what? They need heat to survive. They need also food. But during winter, there's no food. Okay. So they need to migrate. One good example of your migrating birds are your dove, kalapati, okay, or pati in Bisaya. Okay, they are actually migrating birds. They're not local, right? Global wind circulation. Heat and moisture distributed by global winds affect climate. Okay, the uneven heating of Earth's surface causes heat exchange between cold and warm regions. The exchange is facilitated by the movement of air and moisture from the bodies of water like oceans. Remember that the water cycle started everything. Okay, when there is evaporation, there is also condensation, and of course, because of the wind circulation, this is actually distributed in all parts of the earth. Okay, warm air is constantly moving towards the poles, while cold air moves towards the equator. And moreover, air rises at low pressure areas and sinks at high temperature areas, okay, or high pressure areas. This temperature and pressure, okay, driven movements of air give rise to three circulation system, namely the tropical or shade-leaf cell, the temperate or spiral cell, and the polar cell. Okay? Each of these circulation systems aids the distribution of heat throughout the Earth's surface. Let's move now to the bodies of water. Okay? Talking about bodies of water, it actually plays a vital role in these climatic changes or climatic conditions. Why? The temperature of large bodies of water such as lakes, seas, and oceans affect the temperature of air above them. You remember, when this water evaporated, okay, because of heat, it actually what? Moves on the upper or moves on the atmosphere. Okay. The temperature of water in lakes and seas and the oceans influences changes in temperature in the air above them. These bodies of water cool down and heat up slowly compared to the land masses. Okay. Oceanic currents transport heat from the transport heat from equator towards the poles to ensure balance in global temperature. Warm air is transported from the low latitude areas to high latitude areas, while cold air is transferred from high latitude areas to low latitude areas. From area, the great concentration to lesser concentration. From areas of cold to hot, from hot to cold, okay? And those are the patterns. Okay, if you're going to look at the patterns, this is the pattern now. Okay. Warm air is moving towards the Atlantic Ocean, while cold air is moving towards the Pacific Ocean, okay, going to the Indian Ocean, and so on. This is the pattern. Okay. Topography. Topography affects the amount of precipitation in a region. Precipitation means what? Rainfall. Okay. The windward side of the mountain has a wet and cold climate, while the leeward side has a dry and warm climate. Let's take a look at it later, right? Topographic features, specifically mountain ranges, influence the amount of precipitation in the region. Air coming from the windward side of the mountain is moist or moisty. As it rises up to the mountain slope, it cools and condenses, forming clouds and later precipitation. Some warm air continues to rise and descend in the leeward side. Sure, you're talking about leeward and talking about leeward side and the mountain side. What's with this? Okay, let's take a look at it later, right? Windward and leeward. What's with the leeward and the windward? On the other side, the high pressure and high temperature cause evaporation to occur. Once air reaches the side of the mountain, moisture in the air is lost. Okay, a condition called rain shadow is created in a dry area of the mountain's leeward side. What's with the leeward and the windward? Okay, this is the leeward side. Okay, and this is the windward side. Okay, as you can see, the air here is moisty because there is a water. Okay, there is a water, and usually precipitation actually prevails in this area. Okay, cold wind is seen here, while on the leeward side, it's hot air. Okay, altitude. Altitude is the height above sea level. Okay, the higher the altitude is, the colder the climate. Okay, this is the reason why if you're going to go to Busai, it is much colder there compared to the city side. Okay, and of course there is a rise of pressure. That is why if you're going to observe your ears will actually respond to what? The pressure. Air is colder on the top of the mountain since less air can absorb heat. As you go up in the mountain, you need to prepare for a colder and less air. For every 1,000 meters, the temperature drops by 6.5 degrees Celsius. Air pressure also contributes to the decreased temperature. Air pressure decreases, temperature also decreases. Okay? So if you're going to check on the highest peak, what is the highest peak of Earth? What is the highest peak of Earth?
Mount Everest.
Mount Everest, correct. If you're going to check on Mount Everest, there are a lot of cases that mountaineers died there. Sure. Why? Number one, there is less air pressure, and also less temperature. Okay. So their lungs collapses in the middle, and of course, because of this low temperature, their body will react on it and eventually can kill them. Okay. I asked also some of my colleagues in the science department why some of the bodies there are a lot of bodies there, dead bodies, preserved in ice, are not actually removed in the process. They actually stayed there, preserved on ice. Okay? They're telling me that we cannot actually remove them. Why? Because if we remove them, it could be either there could be a chance that the slope will what will fall. Okay, if you are going to remove them, some of the ice will fall. So they will become part of those mountain in the Mount Everest. Okay, let's move forward. Vegetation. Vegetation affects temperature and amount of precipitation in a region. Okay, vegetation can affect the temperature due to its capability to absorb and release energy from sun. Vegetation means plants. Okay, the kinds of plants that we are actually having. When plants release water vapor during transpiration, it adds up to the formation of clouds and later precipitation. Okay. World climates. Now, those are local climates. We have also world climates. World climates are classified based on the environmental conditions, such as temperature, humidity, and amount of precipitation or rainfall, and the natural vegetation that exists in the area for a long period of time. Okay? The Greek philosopher Aristotle was the first to classify climates based on the region from the equator. His division of latitude are still known. We are actually using it until now. They are the equator, Tropic of Cancer and Tropic of Capricorn, and the Arctic and the Antarctic circles. Okay? This is the classification of Aristotle. As you can see, Tropic of Cancer is in here. We are located in the Tropic of Cancer. Okay, the lower of the equator is the Tropic of Capricorn. It is considered as the torrid zone. Okay, in between the Tropic of Cancer and Arctic Circle is the temperate zone. Okay, this is where the 4 seasons are actually experienced. Okay, in between the Tropic of Capricorn and the Antarctic Circle, still the temperate zone or temperature zone. Okay, again, this is where the 4 seasons are actually experienced. Okay, the last part is the frigid zone. This is the Arctic Circle, and the lower part is the Antarctic Circle. And this is based on Aristotle's climate classification or climatic classification. Modern classification was brought by Alexander von Humboldt, who drew a global map with the mean temperature, and Vladimir Köppen, who refined the Humboldt's map and added seasonal temperature range. Okay, Köppen climate classification. Okay, why do we need to know bits of this? Simply because these are used globally. Okay, these are used globally. This is the reason why if a certain typhoon reaches or shall we say bulges from different countries, it has its global name. Okay, but if reaches the Philippine area of responsibility, or it will have its local name. Okay, Köppen climate classification classifies climates based on the temperature and amount of precipitation in the region. So again, this is based on the what? Based on the temperature and the amount of precipitation per month. Okay, it was developed by Vladimir Peter Köppen. Okay, it was brought about his works on the improvement of Humboldt's map in 1884. Okay, as you can see, if you're going to check on them, these scientists, they are considered scientists. They usually the works of other scientists usually caters with their name. Okay, so that the continuation of the work, like for example, if you're going to continue the work of Einstein, it should be under the name of Einstein, but you need to continue with the work. So those are how science works also. Okay, the transfer of ideas and the continuation of ideas. Okay, as a botanist, he based his classification for climates was patterned after Carl Linnaeus' classification for plants, because he is a botanist, okay? And look Howard's classification on clouds, okay? Köppen later improved his classification, okay, in 1918 and in 1936 with the Rudolf Geiger, okay? The system is based on the mean monthly temperature. I told you a while ago that this is monthly, okay, per month, and the amount of precipitation in a region. It has 5 classifications, namely the equatorial climate, okay, the arid or dry climate, the warm temperate climate, the snow climate, okay, because this is based on, again, based on plants and based on what he actually observed, and the polar climate. Each major classification is represented by A, B, C, D, and E. Okay, subclass or subclassification are represented with additional letters. Okay, the second letter is for precipitation, while the third letter is for temperature. All major classifications are defined by temperature, except type B climate. So these are the few, okay? These are few classification according to Köppen or Köppen climatic classification. Okay. Again, A, B, C, D, and E. Okay. These are few. And it was classified. The second letter is based on the rainfall. Okay. And so on. Let's tackle climatic changes by next meeting. Since we have lesser time, it's 8 minutes. And I need more time for this to discuss simply because we are affected by this. All of the organisms on Earth are affected with climatic changes or these climatic changes, right? Do you have any questions so far? Questions so far?
None so far.
All right. If you have, please let me know so that I can address your concern. And of course, you can also interact during the discussion. If you have something to say, just let me know, right? Okay. Again, reminding everybody to please check on your activities and do not wait for tomorrow what you can do for today. Again, you cannot blame me since I already given you a lot of chances, right? I think that will be all for today, class. Thank you for participation, grade 9. Have a nice day, everyone. Take care. Bye-bye.